Hello, and welcome to the first episode of study session for AP Calculus BC. And in this episode, we'll be doing just basic trig review for your up and coming AP Calculus BC year. And these are just important things to be able to do, are kind of fundamental to your ability to perform calculus. Apologies for using MS Paint. I've yet to install a new program. It's the first episode, going to be a bit ragtag. I probably should, but, I kind of just want to pump out the first episode or whatnot. So the first problem is secant of x equals, and this is asking for the following trig identity. Okay, so secant, I always remember this as, I know it's 1 over cosine because, I want to think it's sine because it starts with an s, but it's 1 over cosine, and then cosecant of x would equal 1 over sine of x. I just always remember it because I'm like, I think that should be sine, but I know it's cosine. So, and I think that this should be cosine, but I know it's sine. So that's how I remember it. So the next, oops, I want that there. Okay. The next problem is secant. Oh, that's going to be annoying. You know what? I'll just do that. Sorry about that. So the next problem is Yeah, I definitely need a better program for this because it doesn't want me to be able to just have the pen. I need to program in my pen, so it goes back to pen. Okay, so the next problem is secant at 3 pi over 4 equals question mark. So if we go back from the last question, secant equals 1 over cosine. And if we recall, 3 pi over 4 would be right here. And on the unit circle, anything that ends in a 4 will be, for sine or cosine, will be plus or minus square root of 2 over 2. Okay, and at 3 pi over 4, cosine is the x value on the unit circle. And we can tell that the x is negative in the second quadrant. There's also a method that you can do. You draw your quadrants, and then all students take calculus, and all of the trigs are positive in the first quadrant. Sine is positive in the second quadrant, tangent positive in third, and cosine positive in fourth. And their reciprocals will also be, so like cosecant, cotangent, and secant will all respectively be positive or negative in each of those following quadrants. But since we know this is negative, and we know from the unit circle it has to be square root of 2 over 2, we can rewrite this as 1 over square root of 2 over 2, since secant is 1 over cosine. So we do that, and it's actually negative square root of 2, sorry. I forgot to add my negative. I mentioned it, but I forgot to add it. So 1 over square root of 2 over 2, negative square root of 2 over 2 can be rewritten as 2 over square root of 2. And we multiply this by the square root of 2 because we need to rationalize the denominator. So whenever we do that, we get negative 2 square root of 2 over 2. 2's cancel out, and you end up with negative square root of 2. So that's that problem. Then I need to go back and get the pen. This is, apologies, bit ragtag, but I can at least help you, hopefully. Did I grab the wrong thing? No, I grabbed the right thing. Sick. Okay, so the next problem is where does sine of x, so it's essentially sine negative of x equals, disregard the x. So sine, so the, arc sine of 1/2, okay, so arc sine of 1/2, restricted to pi halves is less than or equal, or is not equal, less than x, which is less than pi. So if we quickly draw a quick unit circle with no circle, just the x and y plane, we see that x is less than pi halves, greater than pi halves, but less than pi. So that means that, so since this is pi over 2, it means that it has to be in this area. And wants to know where sine, because that's what arc sine is. It's sine to the negative, with the negative first exponent on it. It's not an actual exponent. That's just how they show it. But it's asking where that is 1/2. And we know that whenever sine is at its highest point, it's going to be square root of 3 over 2. and it's at its lowest point, it's going to be 1/2. So at its lowest point, that will be a denominator of 6 on the unit circle, so we get 5 pi over 6, and it is positive because the y value, which is sine, is positive there. So the answer to this particular question would be 5 pi over 6. If it wasn't bounded to this domain, like let's say it was bounded to, from 0, we'll call it 0 pi, you would also have to include pi over 6 because at this, sine is also equal to 1/2. So that's that problem. Let me quickly erase all this. Oh, man, this is so tedious. Erasing all of it with this ragtag method. But hopefully, if you get anything out of this, you might not get calculus, but you will learn not to make math tutorials using MS Paint. So that's that. Here it says here is another problem. If secant of x is greater than 0 and tangent of x is less than 0, what quadrants is x located in? Okay, so to make this simpler, I'm going to write secant as 1 over cosine of x is greater than 0. Okay, so if we go back to drawing that diagram I drew before, so all students take calculus. Okay, so it says that secant, which is 1 over cosine, has to be greater than 0. So that narrows it down to the first and the fourth quadrants. Okay, and it also says that tangent has to be less than 0, so it has to be negative. So that leaves only the fourth quadrant available. So the correct answer is quadrant number 4. Hopefully I can just Control-Z all this one away. That's annoying. That's really annoying. I'm going to go a step forward or 2. Yeah, much apologies about that. You know what? I'm just going to do this. Okay. So another problem is, okay, so let's get into some trig equations. So 2 cosine of x, sorry, that was like a merger of an x and an s, plus the square of 3 equals 0. And, there's no domain restrictions on this, but, it's assumed from 0 to 2 pi is your domain restriction. So to solve this, you of course you want to get all your trig functions on one side. So you minus square root of 3 minus square root of 3, and you get 2 cosine of x equals negative square root of 3. Okay, and then you divide by 2 to get the cosine of x by itself. So cosine of x equals negative square root of 3 over 2. So here you reference unit circle, and cosine will always be at its square root of 3 over 2 plus or minus. Whenever it's over 6, you have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. If you recall, x value is the cosine is the x value. So the only time whenever x value is negative, and it can be square root of 3 over 2 is 5 pi over 6 or 7 pi over 6 because they fall on the negative side of the x-axis. So your correct answers are 5 pi over 6, and 7 pi over 6. So that is that problem done. Oh my goodness, I really do apologize for me having to paste and then grab the pen back out. So another problem is okay. So let's do some fun ones where you have to think about them, think about what each is. Okay. So here on this problem, we want to get the left side and the right side are equivalent, and we essentially want to prove that. So on this first one, we get tangent of x times cotangent x equals 1. So we can prove this one or two ways. First off, cotangent is 1 over tangent, and if we multiply those, we get tangent over tangent, and any x over x, or any for x for any value except for 0 will be 1. So tangent over tangent equals 1. Or we can prove this as breaking it into parts, which is essentially the same thing, but sine over cosine times cosine over sine, and these will cancel out, these will cancel out, equals 1. That was a pretty simple one. Oh my goodness, that's so annoying. And then I have to go back and grab the pencil again. Okay. So next problem, I'm going to skip one. So you get tangent of theta, that's a theta, times cosine of theta. My own, the cosine looks more like a theta than either of those, equals sine of theta. And again, this is a fairly simple one. So the best way to do it is anytime you see tan or something that's not sine or cosine, you want to break it into parts. So you get sine over cosine times cosine. And of course, those will cancel out and you end up with sine of theta. Yeah, so that was, again, a fairly simple one. Oh man, I did it again. Don't use MS Paint. It's such a pain. But I just really want to make a video and upload it. I'll just go ahead and do the last one because it's more than likely the most difficult. So you have sine of theta over cosine of theta plus cosine of theta over sine of theta equals cosecant of theta times secant of theta. So cosecant of theta times secant of theta is just 1 over sine times 1 over cos. So 1 over sine cos. So we'll remember that as we're doing this. Okay. So the denominators on these are different. So we know that we'll have to multiply across. So if we multiply this both sides, or the numerator and the denominator by sine, we get sine squared over sine cos plus, and then we have to multiply this by both numerator and denominator by cosine. And we get cos squared over sine cos. And again, I'm multiplying by, I'm multiplying these by the denominator of this, and then that by the denominator of that. So both the numerator and the denominator in this on this side get multiplied by cosine. That's where we get cosine squared and sine cos. And the numerator and denominator over here both get multiplied by sine. That's where we get sine squared and sine cos. And now that since they have the same denominator, we can add them, and we get sine squared plus cos squared over sine cos. And if you remember, sine squared plus cos squared equals 1, and I'll prove that here in a second after I finish this problem. So you get 1 over sine cos, which is equal to 1 over sine times 1 over cos equals cosecant times secant. So now to prove that sine squared plus cosine squared equals 1, just in case you're wondering, and then I will end this video. Other than what I've shown though, obviously it's good to know your unit circle, good to know your half and double angle formulas. I found those very handy as I was learning calculus. Yeah, just be solid with trig. Trig is one of the best things that you need to be solid with. Okay, so we know that a squared plus b squared equals c squared. So if we draw, that x was actually, those were actually really bad lines. But if we draw, graph, this is y, this is x. Your y-axis, your x-axis, and this is only the first quadrant. Okay, let's draw a right triangle. That was really bad. Okay, a right triangle. Okay, so this length right here, if we have a point, we'll call this x comma y. The length of this point is equal to y, and the length of that is equal to x. Okay, so x, we can redefine a squared plus b squared equals c squared, and in a unit circle, hypotenuse is 1. So we'll redefine that because this would be c, and this would be we'll call that a, or we'll call that a. We'll call that b. So you can redefine this as x squared plus y squared equals, and then this is h, so it's a hypotenuse. So we'll call that, or in this case it's 1, so equals 1 squared. And 1 squared is simply 1, so I'll just cross that out. But, okay, so on this, so like let's say we had an angle. We have the angle, we'll just call this 30 or 60. It looks more like a 60, even though obviously that's clearly a 45-degree angle, but we'll call it 60. So the y value, so sine of 60, so the opposite over hypotenuse equals opposite, the angle opposite to the angle over hypotenuse. In this case, the hypotenuse equals 1. So it's simply equal to opposite. So sine of an angle is equal to the opposite, which is equal to y. So you can rewrite y squared as sine squared. And then, so you can do the same thing for O. The cosine of 60 equals adjacent over hypotenuse. The adjacent side is x in this case, and the hypotenuse is also 1. So you can cross out the h, so cosine of 60 equals a equals x. So you get cosine squared equals your hypotenuse squared, is 1 squared, and so 1 squared simplifies down to 1, so cosine squared plus sine squared equals 1. And from there you can derive all the other trig identities by either dividing by like cosine squared or sine squared or whatever you really want. You can rearrange that how you want. But this has been this video. Hopefully it's helpful. I will be making them throughout the whole year as I'm taking a calculus class, even though I already know it. But just for good review. But yeah, I will be making future videos. Hopefully you guys can stay tuned. Hopefully it helps. If you didn't learn any calculus or any trig from this video, this isn't really a calculus heavy video. Hopefully you learned not to use MS Paint if you're recording these type of videos, because I certainly did, although I probably will still use it on the next video. All right, see you guys later.